Hello, I am Giuseppe Melfi from the University of Neuchâtel, Switzerland. Today, I introduce you my paper on the conditional infiniteness of primitive word numbers, a paper that I wrote in 2014. A word number is a positive integer n for which the sum of its divisors is bigger than 2n, but such that it is not a sum of its proper divisors. Roughly speaking, a positive integer n such that the sum of its divisors exceeds 2n has several divisors, and often such an n can be expressible as a sum of distinct proper divisors. When this is not the case, the number is called word. This definition is due to Benkowski, who proposed some problems on word numbers on the American Mathematical Monthly in 1972. In 1974, Benkowski and Erdős proved many properties of word numbers. In particular, word numbers have the simple property that if n is word and p is a prime bigger than the sum of divisors of n, then n times p is word. So, on a hand, there are infinitely many word numbers. And indeed, Benkowski and Erdős proved that word numbers have positive asymptotic density. On the other hand, Benkowski and Erdős define a primitive word number as a word number that is not a multiple of another word number. Benkowski and Erdős raised the question of determining if there exist infinitely many primitive word numbers or not. But this question has been an open question for decades. In this paper, I proved that by assuming classical conjectures, as for example the well-known Cramer conjecture on the distribution of primes in short intervals, then there exist infinitely many primitive word numbers. The proof allows constructing primitive word numbers if one finds two primes, let's say p and q, in suitable neighborhoods close to an arbitrary power of 2. The primitive word numbers provided in this way are all of the forms 2 to the k, p, q. As a consequence of this constructive method, we are able to exhibit primitive word numbers much larger than the known records.